Get back here, mad freak!
Well, you're probably wondering how I got here. Let's go back to the 5th grade. We'll start there.
Alright, 5th graders, who can tell me the probability of you guys passing this math class?
What's probability?
It's like 1.347.
Wow, that's awesome. You're so good at math. You're gonna go so far in life.
A couple of years later, you can see my happy family. And when it started to fall apart. Losing pretty much about everything, I turned to gambling in the casino.
I'm all in.
I'm all in.
All in.
Pass. Hit or stay?
Hello, welcome to the inside of my brain. This is where I do my math and make my money. Okay, first we're going to start with a game of blackjack. There are 52 cards in the deck as we know, and once all the dealer has done his work, we're going to have 46 cards. That moves down to 45 once the person next to me hit, and as we saw, they busted. They had a 5 plus a jack plus a 9. We're going to keep that for later. They got a 24, which meant they busted. My odds are pretty much in my favor. Since I have a 6 and a 5, all I need is a 10, right? And that's a really popular combination and something that we really want to use in blackjack. So what do we need? Well, most favorably, it would be a 10. So there are 4 out of 45 10s in the deck since we haven't seen it. So best case scenario, it's going to be 4 out of 45. Another ideal scenario would be a 9 plus an ace, which would be basically 4 out of 45 multiplied by 3 out of 44. Those would be the probable odds of getting a 9 out of an ace, or a 9 and an ace, and that's pretty much the same for an 8 and a 2, 7 and a 3, anything that we don't know already exists. Now, my worst case scenario will be a 5. We don't want that, because with a 5, we already see how there is already a 5 there. So it would be a 2 out of 45 multiplied by a 1 out of 44. So we would need a really, really high chance of pulling this. But if I get a 5, let's see how lucky I can be. And just for the record, the odds of me getting both 5s in a row is 0.001%. So that is not very highly probable.
Pass.
Hit.
Reveal your cards.
21.
Everyone chip in.
We're on the gambling streak. We're gonna play some poker. This is a fun game. From the person next to me, I could see from their glasses that they had 4 cards. I could see they had a king, a 6, a 5, and an 8, so that will eliminate 4 cards. We know the probability of those. And my cards were an ace, a queen, a jack, a 5, and a 4. These were all apart, so we have the ability to get a royal flush. All we need is a king and a 10. It's not like we can get a 10 and a 9, or a 10 or a 9. We can't get that. Royal flush is king, ace, queen, jack, 10. All of the same straight, all of the same heart. So we need a king and a 10. Now this is really low since one player has 5 cards, the other player has 5 cards, and we put back 3, and that turns the 52 cards into 42, and then to a 39. So it's going to be 1 out of 39 to get either the king or the 10, and then to get the following would be a 1 out of 38, which is really low odds. It's about 6.747 times 10 to the negative 4th over 100. This would be the probability, which is super low, but we're gonna go for it anyways.
Royal flush.
Chip
sleeping.
Okay, here's another game of poker. It's kind of my favorite game. So in this game, our hand, I couldn't see the other person's hand, so we're not going to be able to use that. But we have 5 of hearts, a 4 of diamonds, and most importantly, a 2 of clubs, which I can draw, an ace and a 3 of clubs. And so what we want to focus on are these right here. And there's 2 ways to get a flush in this hand. We can go from the ace and have a king, queen, and then it would be king, it would be, queen, king, ace, 2, 3. That would all be in sequential order, or it could be 3, 4, 5. All of that would work. So we have pretty high probabilities then, since we have kind of 4 possibilities. Then we have a 4 over 42 chance, since the other person has 5 cards and we have 5 cards. And you subtract that by 52. And so it's that. But then once you get one of these cards, then you only have a 1 out of 41 chance to get that selected card, which is a simple equation. It's 4 out of 42 divided by, or 4 out of 42 times 1 over 42, which will get you 0.002267 of a chance, percent chance, which isn't that bad. So we're gonna go ahead and roll with that and see if we can get it.
Reveal your hands.
Okay, and then I gotta take it. Alright, dealer, deal me in.
You're drunk, man. Go home.
Okay.
Go!
Let's try the slot machine.
The best thing about casinos is that when you're tired of playing card games, there's always something else to do. Here I pick a slot machine, and we can kind of easily calculate this. This is a pretty easy slot machine with basically 3 different slots, and each of them has basically 3 chances. You can get an A, a B, or a C from each of these spaces, so there's a 1/3 chance in each. And this is a very simple equation. We just have to multiply these probabilities. It goes from 0.3% chance to 0.1 repeating to 0.037. Now, you don't win a lot from the slot machine, but since it's only 25 cents to play and you have a 0.03% chance of winning, it's pretty much worth giving it a shot. And here we got lucky and went ahead and won.
Hey, dealer. How about you deal me your number?
Knock it off, man.
Hey, is this guy bothering you? Listen, your chances with her are uncalculable. Get out of here. Guards.
Thanks, man.
What are the chances you and me get a drink?
Oh, sure.
Man, I can't wait for that drink.
Hey, smarty pants, you wanna play a game?
Not really. You're drunk, man. You should go home.
A game of Russian roulette.
No, please.
Okay, I don't know what's happening here, but there's a man and he's going to shoot me in a game of Russian roulette, but only I am the one being shot. So with the revolver that he's using, it has 6 barrels, so we have a 1 out of 6 chance of getting shot, and every time from that, it would be a 1/5, a 1/4, and a 1/3. This does not look like a highly probable situation on the first half, because we have a 1/6 chance of getting hit, but every single time it goes down to, this becomes 0.03 percent chance, and it goes on and gets worse and worse. For the person, the number gets smaller and smaller of the percent that we would actually survive this, up until 1/3, which is 0.0027, repeating, which is a really low percentage. We almost have a 99% chance of death. So we want to avoid this situation and hopefully something comes up.
Come on, man. 1/3 chance I'm gonna die. You want that on your hands?
I just want to see how lucky you were. Hey! Oh, jeez! Okay.
I'm fine. What about we get a drink?
Why, hello, sir. How much for a game of Texas Hold'em? Not much of a talker, I see. But look, I won. Cheater.
So in this casino, it's really interesting. They had a new game that they were proposing, and that's what I was working on in my worksheet. Because what I read in the newspaper was that there was a wheel. I'll make that a little bit bigger, where you can win $1, $0, $0, or $100. And this was $4 for an entrance fee. And with this, we can make a probability distribution table. You lose $4 every time you land on a 0, and you have a 1/2 chance, or just to make it easier, a 1/4 chance, 2/4 chance, I'm so sorry, of landing on that. And then you have to lose $3, which would be landing on a 1. You have a 1/4 chance, but you have the same chance as to lose $3 as to make $96. And so if we multiply all of these together, we get -2, -0.75, and 24. And so if we add all of these together, minus 0.75 plus 24, on average, you're going to be making $21.25. So if I can stay in this casino a little bit longer, I'm definitely going to take these odds, because it's a complete steal.
Oh man, let's see how much money I'm gonna get today.
That's him. Get him.
Get back here, mad freak!
Okay, I don't know why these guys are after me, but I don't think they're going to stop. So in this equation, we have 2 doors, and each of those doors basically have a lock on them. The first door has a basically 3-slot lock, and it's a 1 through 10 number system. So it's 1 through 10 on each of these, but order does matter. It's a permutation equation. You can't have repeating numbers, so you can't do 2, 2, 2. On the other hand, the other door has 4 slots, and it is a combination, so you can have 4, 4, 4, 4. So it would be, and it's also 1 through 10. So knowing this, we can set up our equation. We know this is a combination, this is a permutation. There are 40 possibilities, and we need 4 numbers. And over here, it's a permutation. We have 30 possibilities and 3 numbers. We can work through this math in a better exemplified way. With the permutation, it would be n, which is the number of total objects, divided by n minus r factorial. And if we kind of figure this out, it would be 24,360 different combinations. And over here, the equation is slightly different. It's r, which is the number of choosing objects, times n minus r factorial. And again, that is the denominator to n factorial. But that number really doesn't change, and it's actually a lot higher. It's 91,360. These guys are 5 seconds away, so to do any of these in 5 seconds, my probability would be really low. So I'm just gonna go ahead and kick the door.
Too much math.
Oh, I didn't expect to see you here. Going back into gamble again?
I'm done with gambling. I want a 100% chance with you.
There used to be a graying tower alone on the sea. You became the light on the dark side of me.